Hello, Mr. Jenkins here with your next lesson in Chapter 8. This will be Section 8.3, which is multiplying binomials. So our last lesson, 8.2, we talked about some multiplication and division, but that was with a monomial, so different game if we're talking about a binomial, which hopefully you'll remember means a two-term polynomial. So specifically, we're looking at how do we, your most important skill, your learning target, how do we multiply two binomials? And I would just say this last part is not as important. A binomial and a trinomial that you will probably not be tested on, but anyways, it will further your, if you can do that, you can definitely do a binomial times a binomial. Okay, with all that said, this examples 1 through 3 will be the exact same types of problems. I'm just showing you alternative ways to think about them, okay? So just to preface that, I want to just say you should kind of maybe zero in on one of the methods and use that one consistently. The one that I like the most is here in example 1, and it's just the good old distributive property. The thing you have to remember, though, is that if you're taking a binomial times multiple terms, you have to distribute both terms, okay? So you take 2x times all of the next binomial, so times 3x minus 7. And we know how to work that out. We've done that several times, but this is going to be your new part. You also have to distribute the plus 4. Times the 3x minus 7. You don't necessarily have to write it out this way. You might just remember that. I'm taking 2x times these, and then I'm taking plus 4 times these, okay? All right, so what we end up with is 2x times 3x is 6x squared. 2x times minus 7 is minus 14x. Now to the plus 4, 4 times 3x is plus 12x. 4 times minus 7 is minus 28. And then a lot of times you'll have like terms there in the middle. So you'll have that next step of combining your like terms or simplifying. So our final answer here would be 6x squared. Then you have negative 14 plus 12 would be minus 2. So minus 2x minus 28. A lot of times what you'll get if you take a first degree binomial times a first degree binomial is you'll get a quadratic trinomial. Not every time, but that's what you'll get a lot, okay? I believe MathXL will accept this, but remember from the last lesson, you could factor out a 2 from that. So you could also write that as 2 times the quantity 3x squared minus x minus 14. Like I said, I think MathXL will accept it this way. All right, let's look at one more that way. So this time we have a second degree term. So this will be a little bit different look. So same process though. So we're going to multiply the x squared times 4x plus 3. And then the minus 6x. Got to close my parentheses. Then the minus 6x times the 4x plus 3 as well. All right, distributing the x squared is going to give me 4x cubed plus 3x squared, and then the minus 6x, I'm going to get minus 24x squared and minus 18x. Then I want to check for any like terms. So I have those there in the middle, those x squared terms. So final answer here, 4x cubed plus 3 and minus 24 make minus 21 x squared, and then minus 18x. So again, I believe that's acceptable. There is a common factor there, a greatest common factor. So my question for you is, what is the greatest common factor? And then maybe what's this look like factored out? So now we're going back to the last lesson. Okay, you can find that on the notes if you have any trouble. All right, so example 1 would be my preference on these. Example 2 and 3 are alternative ways that you can show your work. Okay, if you like those, I suggest you use those. That said, I'm only going to show one of each of those. Okay, if you want to see example B worked out, you might look at the notes. Okay, so you can use a table as well. All right, if you have 2 terms times 2 terms, you want to make a 2 by 2 table. So that's just going to be like a box split vertically and horizontally. So you have 1, 2, 3, 4 spaces. All right, so the x and the -3, you can either put on top or on the side. And then the 4x and the -5 would go on the other spot. All right, so now each box is going to represent a multiplication. So this box right here would be 4x times x, so 4x squared. Right here we'd have 4x times -3, so minus 12x. Here we'd have -5 times x, or -5x. And then here we'd have -5 times -3, or plus 15. All right, and then you just want to write out your final answer. So we have our 4x squared term and no other term, no other like term, so 4x squared. -5x and -12x are like terms, so we're going to write that as a single minus 17x, and then there's a plus 15 by itself. So 4x squared minus 17x plus 15. All right, and like I said, B has worked out the same way. If you think you like the table, you might check that out on the notes. And then your last method, this is how they used to teach this back when, when I was in school. They called it the FOIL method. So that's an acronym, as you might have guessed. So that means first, outside, inside, last. So let's look at exactly how that's going to look. So if I multiply the 2 first terms, that's going to be 5x times 2x. And then O would be the 2 outside terms. So that would be 5x times plus 1. Let me let my screen catch up here. I would stand for the 2 inside terms. So that's -3 times 2x. And L stands for your 2 last terms. So -3 and plus 1. Now, if you think about what we're actually doing here, all we did is distribute the 5x and then distribute the -3, okay? So really, this is just a different way to remember to distribute both terms. But if FOIL helps you to remember that, then think about it that way. I really don't care, okay? First, multiplication is going to give me 10x squared. Then we have plus 5x. This would be -6x, so minus 6x. And then that last term would be -3, so minus 3. Combine your 2 middle terms. So my final answer would be 10x squared. Plus 5 and minus 6 make minus 1. So minus 1x or minus x and minus 3. So 10x squared minus x minus 3. So like I said, the big thing to remember from that page, I showed you how to do the same type of problem 3 different ways. You need to zero in on one method and get good at it. My preference is the distributive property. I suggest you pick one and stay with it. All right, so now we will get into a couple of, a little bit of application, a little bit tougher problems. So let's go ahead and look at that. All right. So multiplying a trinomial and a binomial. So order doesn't matter here, but I'm going to choose, and again, I like the distributive property, so I'm going to show it that way. So I'm going to distribute the 2x times the trinomial, so 3x squared plus x minus 5, and then the minus 7 times that same trinomial, 3x squared plus 1x minus 5. All right, so when I distribute the 2x, I'm going to get 6x cubed plus 2x squared minus 10x. Now the minus 7. First term is going to be minus 21x squared, and then minus 7x plus 35. So probably going to have some like terms then at the end. So let's kind of work through those. 6x cubed is the only x cubed term. Then we have, let's see, 2x squared and minus 21x squared. So 2 minus 21 would be minus 19. So minus 19x squared. And you have minus 10x and minus 7x. Negative 10 minus 7 is negative 17. Minus 17x. And then we have that plus 35 that's left there by itself. So plus 35 would be our last term. So altogether, my final answer, 6x cubed minus 19x squared minus 17x plus 35. All right. And like I said, this one wouldn't really be on a test probably. So this would just be for this homework when we're real focused in on this specific skill. And by this kind of problem, I just mean a binomial times a trinomial or something larger. Okay. Big ones are the binomial times the binomial. All right. Then a couple of word problems to finish up. Let's look at it. So this says a cylinder has the dimensions shown in the diagram. What is a polynomial that describes the total volume of the cylinder, right? So volume of a cylinder. This is one from the past. Is going to be basically the area of the base, which is circular base, right? So that's going to be pi times radius squared. And then times the height, so times x plus 4, or sorry, times the height. So that's my formula, and so then we'll go ahead and sub in. So we can sub in. This says x plus 1 is my radius, and then my height is x plus 4. All right, so let's sub in and see how that looks. So volume equals pi times radius, which is x plus 1. So x plus 1 squared times height, which is x plus 4. Okay, so this one right here, most of you would do probably that wrong. You'd probably write something like x squared plus 1 squared or x squared plus 1, like you're distributing the exponent. But remember, what that means is, I'll work that out up here. It just means x plus 1 times x plus 1. All right, and so we would distribute the x and get x squared plus x. Then distribute the 1, and we get plus x and plus 1. Notice that time I wrote it out a little bit differently also, just to save a little bit of time. I just kind of talked you through that. So altogether, that's x squared plus 2x plus 1. So I have that times the quantity x plus 4. So one more of those where we have a binomial times a trinomial. Since I showed the last one with the distributive property, I'll just show this one with a table in case you like a table. And a table might be nice for 2 terms times 3 terms as well, especially if you're more of a visual person. Okay, so I'll set up this multiplication in a table where I want a 2 by 3 table. I'm going to make more of a long rectangle. So for that one, we'd make a 2 by 3. So my 3 terms are x squared, positive 2x, and positive 1. And then my 2 terms are x and positive 4. Then we'll go through this pretty quick. X times x squared is x cubed. X times 2x is 2x squared. X times 1 is x. 4 times x squared is 4x squared. Sorry, these aren't popping up. They will here in a minute. 4 times 2x is 8x. And 4 times 1 is 4. All right, so we have, 6 terms there. Some of them are like terms, so we just want to make sure we don't repeat those like terms, okay? So overall, we'd have pi times, you have x cubed. I'd probably mark these out as I went. X cubed. You have 2x squared plus 4x squared, so plus 6x squared. You have 8x plus 1x. Plus 9x, and then plus 4. All right, so that's going to be our last answer. We'll just leave that in terms of pi. So pi times x cubed plus 6x squared plus 9x plus 4, right? And again, wouldn't have one on a test like this, but if you can do this one, the ones on the test would be easy. That's the idea. All right, and just to save you a little bit of video watching time, I am going to hold off. Actually, I'll start this one, and then I'll have you do the last part. We'll practice that factored form one more time. All right, so shaded region, we've already talked about this. We want to do the big rectangle minus the small rectangle. All right, and these aren't really rectangles. That's just so you can see the dimensions. All right, so my big rectangle is 4y. Sorry, my big rectangle is 4y plus 8 by 6y. So for that, all we have to do is distribute one term. So that'd give me 24y squared plus 48y. All right, and then my little one is a little tougher because we have binomial times binomial. So there we have 4y plus 6 times 4y plus 5. And I know I'm working through this pretty quick, but I just want to get you to the point where you're going to kind of write your answer in factored form. All right, so distribute the 4y. That's going to give me 16y squared plus 20y. Then we're distributing the 6 to get 24y and plus 30. So altogether, 16y squared plus 44y plus 30. Okay, and then so again, we know we want to do big minus little. So this would be 24y squared plus 48y. Minus 16y squared plus 20y. Sorry, 20y plus 24y. We'll call that 44y. I was looking at the wrong spot. $44y and plus 30. All right, so I'm actually going to have you do 2 parts. So step 1 will be to subtract, and then I'll ask you a follow-up to write that in factored form. And that will round out our video. So hopefully this helps. We may review this an extra day because it's a really important skill that you need for everything else that we do kind of for the rest of the year after this. So this is an important one. So stay tuned in and get her done.